Question 6. Explain how ions are accelerated, detected, and have the abundance determined in the time of flight. DOF mass spectrometer. Ions are accelerated by an electric field. Accelerated by electric field. Ions are detected by gaining electrons, and relative abundance is proportional to size of current. So abundance is determined by size of current flowing in the detector, by size of current or amount of electrons gained, but size of current flowing in the detector. So ions are accelerated by an electric field, ions are detected by gaining electrons, and abundance determined by size of current flowing in the detector. 6.2. Calculate the mass of a single 52 Cr plus ion in kg. So we're going to do 52 times by 10 to the power minus 3 divided by 1000 divided by, because we're trying to find the mass of an ion, divided by Avogadro's constant L. So divided by 6.022 times by 10 to the power 23, which is given in the question in brackets. So 52 times by 10 to the power minus 3 all over 6.022 times by 10 to the power 23, 8.64 times by 10 to the power minus 6. .64 times by 10 to the power minus 6. 6.3 in a time of flight mass spectrometer. The kinetic energy was that. First step times both sides by 2. So I get 2ke equals mv squared. Second step, v squared equals 2ke divided by m. Third step, v is equal to square root of 2ke over m. We're given the kinetic energy, and the m is just the mass of the ion, because it says of that same ion, and ion is just a mass in kilograms, so 10 by 10 to the power minus 3 divided by Avogadro's constant. So it's going to be square root of 2 times by kinetic energy, 1.269 times by 10 to the power minus 13 divided by the mass. Yeah, that should just say m. I don't know what I did there. Arrow, no. The mass of the ion, which is 8.64 times by 10 to the power minus 26. And that will give me a pretty large number, but I'll give it in standard form. 1.71 times by 10 to the power of 1, 2, 3, 4, 5, 6. 6, and the units as well of velocity. There's units given in the question: meters per second to the power minus 1, ms to the power minus 1, not meters per second power minus 1, ms to the power minus 1. And then 6.4, bromine has two isotopes, 79 Br and 81 Br, in approximately equal abundance in the time of flight mass spectrometer. Bromine forms ions with formula Br2 plus in square brackets. Sketch the pattern of peaks you would expect to see in the mass spectrum of a sample of bromine. Well, we know that we have 79 and 81 BR. BR, where's BR? Where's bromine? Where's bromine? There we go. So what we're gonna have is, well, we're gonna have 3 peaks, one at 158, and this one at 158 is gonna be 25%. We're gonna have one at 160 at 50%, and one at 162 at 25%. So 158, 25%, 160, 50%, 162, 25%. And I'm probably going to create a separate video on this question and going into more detail on how you approach it. But this is the correct answer. 158, 25%, 160, 50%, 162, 25%. 6.5. A sample of xenon has AR of that. The sample consists of 4 isotopes. Abundance of 3 isotopes are shown in table 3. The data for one of the isotopes is missing. Use the data to calculate the abundance of isotope MXE and calculate M, the mass number of MXE. So in order to calculate this percentage abundance, we're just going to do 100. Total must add up to 100 minus 28 plus 25 plus 27. So 100 minus 28 plus 25 plus 27, which would give me 20. So I can say that MXE equals 20% in brackets. Okay. Actually, it's, yes, XE and M is the smaller one. But there we go. Now, what does it want me to do? Calculate the mass number of MXE. How would I do that? Okay, that's how I do it. Okay. All I have to do, because I know that AR is 131.31, AR is equal to this times by this, plus this times by this, plus this times by this, plus this times by this, but we don't know this, and therefore we're going to have to use algebra as well. That's why it's worth 4 marks for the whole question. Otherwise, if you're just substituting values in, it'd be worth 2-3 marks at max. Plus, we'll just say let MXE equal y, so we get y times by 20 all over 100 as well, this percentage. So now we can times by 100, we get 13131 equals, I've put all these values in my calculator, 129 times by 28 plus 131 times by 25 plus 132 times by 27, 10, 4, 5, 1 plus 20y. I'll get 13131 minus 10451. 20y equals, well, 13131 minus 10451 will give me 2680. And then do 2680 divided by 20, and I'll get y is equal to 134. Hence, the mass number of MXE is 134. Okay, slightly tricky, but yeah, shouldn't be too bad. And that is the end of question 6.